Okay then, in this video we're going to be covering IDEs or integrated development environments. We're going to have a look at some different types of errors, and we're also going to have a look at libraries. So to start with then, IDE. This is the program that you tend to write code in. Now you've probably used a few over the years, sort of back in year 7 and 8 we maybe even used something called PyCharm, which was quite complicated, probably looks a little bit like the one on the left there. We've more recently been using Thonny at school, which is a very cut down version of an IDE, and you might have also used IDLE, which is Python's kind of own version of an IDE, which again is very cut down, doesn't have many features, but obviously it makes it ideal for us at school. But if you're sort of doing programming as a job, there's lots of features within the software called an IDE that's going to help with your programming, and for the exam students really need to know about these different features. So let's have a look at some of them. So to start with, the main one obviously is the editor. This is the main part of the window, usually the biggest part of the window, that allows the programmer to enter, format and edit their code. Sort of when you're using Thonny or IDLE at school, this is the main window where you're writing your code. So if this question does ever come up, this is obviously a nice easy one to pick out. It's where you enter, format and edit any of your code. So some other ones then, you've got things called compilers. You will probably recognise the word compile from when we've done Greenfoot in the past. You click on the compile button, and what that does is it converts your code into machine code, and what it does is it creates a file called an executable file, an exe file, that anytime you click on it or open it up, it opens your program. It doesn't have to recompile your code every time. So when we're using Python, we're actually using something called an interpreter, and when we use Greenfoot we're using a compiler. So an interpreter converts each line of source code into machine code and executes each line as it's run. So every time you open and run a Python file, it has to interpret that code and convert it into machine code every single time. Now obviously, for Python, for the programs that we're running, that's not a problem. It allows us to do a lot of easy debugging, because we can just sort of keep opening it and running it and seeing where it fails. Whereas a compiler, if you've got a big program, it could take quite a long time to compile, and you're not going to know if it's going to work until after it's finished compiling. So another thing then that you've got is a linker. This allows any previously written code or libraries to be linked into your code. So if you say import random in Python, that's using the linker to link some previously written code which is stored in a library. We're going to look at libraries in a second if you've forgotten what they are. A loader. This is a program which loads previously compiled code into memory. So any code that you've previously written, that loads that into the memory. Probably a more difficult one to remember, I would say, for an exam question. There's much more easy ones like these. So you've got Debugger. This is a part of the program that allows you to locate, identify and rectify any errors in a program. There's also something, obviously the debugger, it's something that you can just run, and it highlights where your errors in the code are. Trace. This shows you which lines of code are running in which order, and it's obviously useful if your program's sort of jumping around in and out of if statements and loops. You can see which lines of code have been run in which order, and it might also show you what the values of the variables are as it's running. A breakpoint. This is a really useful, sort of probably one of the most used features. This is, you can sort of put a stop point in, and your code will stop running at that specific point, and then you can go through it sort of one step at a time. So you sort of, imagine pressing the arrow key or, clicking the mouse, and the program runs through one line at a time. So it slows it down so that you can watch what's happening with your code. So, usually to identify where an error is or why you're getting a wrong value appearing at the end of your program. So going through it one line at a time is called single stepping. Variable watch, another really useful facility, and this shows you what's currently being stored in a variable. So as the program's running through, often if you've used a breakpoint and you're going through slowly, because obviously programs run incredibly fast, you can sort of see what's being stored in your variable. So if you're getting a wrong answer come out, you can try and track back and watch what's happening with the variables to see why it is doing what it's doing. Sort of a cheating way of doing this is often, which we tend to do, is just put print and then the name of the variable. So if you're getting the wrong tax coming out, every now and then you just put print tax in your program and it prints it out. Whereas a more sophisticated feature is this variable watch, saves you having to do that in your code. Memory inspector, again probably a more difficult one to remember. It's a facility which will display the contents of a section of memory. So if you're really getting specific with your programs and storing things in different areas of RAM and memory and things like that to optimize them, then you can have a look at where and what things are being stored in memory. Error diagnostics, this is that error message that you get sometimes at the bottom that's sometimes difficult to understand, but it pops up and says, you know, you've got a syntax error, and hopefully what line it's on, and it allows you to go back and then have a look at what that is. So if a program fails to compile or run, you get an error message which helps you diagnose what's gone wrong. You know, sometimes tells you what line it's on and, like I say, what type of error it is. Talking about errors, we're going to have a little look at errors now. So here's a short program here. You can see that we've imported a library up here, or we've tried to, and then it's going to print the word loading. It's going to sleep for 2 seconds, so not do anything. Then it's going to print the word welcome. It's going to ask them for their name, ask them for their age. Then it's going to say if age is over 17, it's going to print out and say you're not old enough to drive. If not, it's going to print out and say you are old enough to drive. So really simple sort of, you know, year 7 style program here. And there's a number of errors within this code. Feel free to pause the video and see if you can identify what they are, sort of challenge yourselves if you like, but I'm going to go through them now anyway, so pause if you want to have a little look for yourselves. Okay, so working through then, the first error, this one up here we could class as a linking error. So this is an error that occurs when a programmer calls a function within the program and the correct library has not been linked to that program. So down here where we're saying sleep 2, that won't work because we've imported our library wrong here because we've spelt sleep wrong. So therefore it won't link to the library correctly. We've also got a syntax error. So in Python, the word print, which is a reserved keyword, this should not have a capital P, and therefore it won't run because this is a syntax error. So this is an error where a command doesn't follow the expected syntax of that language. Missing brackets is a common one. We've also got a runtime error here. So this is an error that only occurs when the program's running, and therefore it's difficult to foresee before the program is compiled and run. So the program would run perfectly fine down to here, but then when it gets to this line, it's going to look for the variable age and it's not going to find it because we're missing a capital letter, or we've got a capital letter really where we shouldn't have a capital letter. So this would run, but then it would stop if we got to this point here. So a logic error, this is where the program seems to run fine, but your output's wrong. Maybe you're getting the wrong value come out, the wrong amount. In this case, the logic to this program isn't right. So if their age is over 17, it says that you can't drive, when obviously it should be the other way around. So our logic error, the program runs fine, you know, if we fixed all the other errors, but this should perhaps be a less than symbol, or we could swap these two sentences round here to make this program work. And obviously it should also be greater than or equal to 17 if we're going to swap them around. So that's a logic error. So another little bit of code here then, nice and simple again. We've got somebody asking to input their height. Again, pause the video if you want to have a little go at doing this yourselves, but we're going to go through the answers now anyway. So asking somebody to enter their height in meters, it's then going to round their height to 0 decimal places, and it's going to say if the person's height is less than or equal to 2, then they're safe to stand under the helicopter. If not, then decapitation is likely. So some errors in this code here then is our rounding error. This is where we've rounded a number to the sort of number of decimal places. In this case we've rounded it to no decimal places, which with a program like this, which is critical to somebody losing their head, it's important that that error is rectified, because if somebody was 2.4 meters tall, this would round it to 2 meters, tell them they're okay to step onto the helicopter, and of course they would get a haircut. So that is a rounding error. A very similar one is a truncation error. This is even more kind of causing more accuracy issues, because if we put the number 34.9 in and we truncated that, this isn't in the program, this one, if we truncated that, it would just nip off the last digit if we truncated it by 1, and therefore it would make 34.9 appear as just 34. So that's actually an error, an accuracy error of minus 0.9. So yeah, truncation errors and rounding errors are very similar, but it just makes your data less accurate. So moving on to the very last section then, looking at libraries. So we've probably used libraries in the past where you've imported random and possibly imported time. Some of you that have written, more complex programs will have imported many different libraries. And essentially, a library is just a collection of code that's previously been written. So actually, the code to generate a random number is quite complex. Every time you wrote a program that you wanted to generate a random number for, often for games, etc., where it needs a little bit of random in there, you're not going to rewrite the code to generate a random number, like properly generate a random number every single time, because you'd be using the system clock to the milliseconds, you'd be doing calculations on it to make what is seemingly a random number. Whereas there's already a library created, so you just have to put import random, which is the library, and then you just generate a random integer. And that code's already written for you. So there's some other examples, things like square root, and random number generators again, and we've talked about time. Examples of subprograms include standard input-output routines such as saving to disk. So again, things like writing to file and things like that, saving files in certain areas. If you're writing programs, there's codes that have already, there's codes library that's already been written for you. So the advantages of that, it means that related private functions and subprograms are stored in the same location. Again, probably a more difficult one for you to remember, unless you can just sort of remember that sentence essentially. It just keeps things nice and, sorry, I keep clicking the mouse. It keeps things nice and organised and stored in the same location. The most common one that people are going to say is that you've saved time, but if you're saying save time, you need to say why, because the answer to most computing questions is it's quicker, easier, but you need to explain why. So time is saved as a programmer can simply use the private functions and the program stored in the library, which saves them rewriting it. I would even add on to an exam question, and maybe even give an example such as random. Subroutines contained in the library have been tested, so they should work reliably and not need further testing. So if you're rewriting the random code, as I keep coming back to, you're going to have to test that every time you write it, whereas the library that's been written already by professionals and been used millions of times, that's solid code. You're not going to have to debug it every single time. And your program's going to contain less code, therefore it's going to be easier to maintain. So, import rand int, or whatever the code is for Python or Java or whatever program you're using, is a lot less code than the probably hundreds of lines of code that is used to generate a random number. So it means to look at your code and edit it and pass it on to somebody else, maybe when you move jobs. It makes it a lot easier to maintain. Okay, so that should cover everything that you need for your 3 lessons or 2 lessons. If there's any problems, I will be on Teams if you need any help.